welcome back to another Marcus Maths video. Today we're going to be continuing with our study of Unit 1, Limits and Continuity of AP Calculus BC. We're going to be solving a lot of these limit expressions today, so a lot more calculus heavy, a lot more calculation heavy. Make sure to like and subscribe if you haven't already. And I was thinking a little bit more, just a quick channel update. On the weekends, I will be doing one SAT math video, or maybe two, one with a skill and one with an overall review. And then I'll also be doing an SAT reading video to help you guys out with that other material as well. So definitely stay tuned for that. Of course, if you have any other suggestions, let me know in the comments. Make sure to subscribe to the channel if you haven't already. Let's go ahead and get started with this first question here. So we can see that we're trying to find the limit of f of x, which is a piecewise function defined by these two different functions right here, as x approaches -4 from the right. This is very important already, because we know from the right, that's only going to be values that x is greater than -4. Those are the values to the right of -4. So we don't even have to worry about this left side of the piecewise. We only need to analyze the limit of this function right here, our 2 to the power of x. So our strategy here, since we don't have any discontinuities that we have to solve out, we can just directly substitute -4 in for x and solve for the limit. So how this would look, we would find the limit of 2 to the power of x as x approaches -4, and this is equal to 2 to the power of -4. If you do not know how to solve this expression right here, highly recommend you refresh upon the rules of exponents, because to get rid of the negative exponent, we simply move the expression to the denominator. So now we have 1 divided by 2 to the power of +4. Then we solve out 2 to the power 4, which is equal to 16. So that means the limit of 2 to the power of x, or f of x, as x approaches -4 from the left if we're dealing with f of x, if approaching -4 if we're dealing to the power 2 to the power of x, we're just left with 1 over 16. Which is the answer here. We don't have to worry about the limit not existing. Once again, we are only analyzing that one-sided limit here. So moving on to this next question, we have a composite function here that we're going to be finding the limits as x approaches 0 of. Our strategy here is to just simply start with our inner function, our h of x, and we're just going to find the limit of h of x as x approaches 0. So to analyze this limit, we can see that the left side is approaching -1 and our right side is also approaching -1. So we know that the limit of h of x as x approaches 0 is equal to -1. And now we're just going to find the limit of f of x as x approaches -1. And since that is unbounded, the limit does not exist. As we can see in the explanation here, we first find the inner function here, and then we analyze the limit of f of x as x approaches -1. Since it is unbounded, we cannot solve the composite limit here. Okay, on to our next question. Instead of composite, we're going to be dividing the two function limits as x approaches 3. So we can split this into two expressions, one for the numerator and one for the denominator. So our strategy here, when we're dealing with multiplication or dividing with our limits, we are simply going to find the limit of each and then divide the two values. Starting with g of x, we can find the limit of g of x as x approaches +3. We approach +3 for the y value on the left side and also on the right side. So that limit is equal to +3. And then we can divide that by the limit of f of x as x approaches +3. We see, unfortunately, that the limit is approaching 0 from either side. So we left with 3 divided by 0. This is undefined, so the limit does not exist for that expression. All right, our next step, we're trying to find the limit of cosine as x approaches 0. We can just do direct substitution here if we know how our cosine function works. If you don't know these trigonometric expressions already, highly suggest that you refresh it on pre-calculus. But really quickly, I guess I'll create a unit circle for us. Let me do this in a coordinate plane. These are really good whenever we're working with any trigonometric expression and we need to find values, because we know that our cosine will be always equal to our x. of our coordinate, and our sign will be equal to the y. So C and S. And we can see here we have 1, 0, 0, 1 up here, negative 1, 0 here, and 0, negative 1 over here. But we are just finding when the value of cosine is 0, that means the radian measure is 0, which means we are lying on this line right there. So that means our point is 1, 0. We take the x value. The x value of this coordinate is 1. So via direct substitution of 0 into our cosine function, the cosine of 0 is equal to positive 1. C is the correct answer with this one. Okay, we're dealing with a rational function here. Find the limit as x approaches positive 5 of x plus 2 divided by x squared minus 5. Okay, what we can do here, direct substitution, we always want to attempt that when we first start out with these questions. Let's try into our denominator, because that's where any discontinuities will form if our denominator is equal to 0. We substitute in 5 into our denominator. We get 25 minus 5, which is equal to 20. We can pursue direct substitution from here. We're not going to encounter any discontinuities in our numerator, because when we substitute in 5, we get 7 on our numerator. Via direct substitution, we can't simplify 7 over 20 anymore. So B is just the correct answer here. No need to overthink these. And our last question, we have limit expressions subtracting from each other. Let's start with h of x and g of x. So we're going to be analyzing the limit as x approaches positive 3 of each. Okay, our first step is to find the limit. So it doesn't look like we can find the limit of h of x as x approaches 3. We are going to look at the one-sided limits from here, because if our one-sided limits are equivalent for the value, we actually can find a real number limit here. Okay, so our first step is to find the limit of h of x as x approaches 3 from the left. That is equal to 2. And then the limit of g of x as x approaches 3 from the left is also equal to 2. So we can subtract. We have equal to 0. And from the right, we have equal to 5 for h of x, and we have equal to 2 once again for g of x. We subtract, we have 3. Our one-sided limits are not similar. This are not equivalent. The limit does not exist. Alright, so this was our video for today, simply solving through these limit problems. We didn't have to eliminate any discontinuities. Probably look forward to that on tomorrow's video. We're going to be actually solving through and not just direct substitution. This should help kind of refresh us with a lot of the functions that we're going to be dealing with in calculus, our trigonometric functions, etc., like we saw with our cosine. I'd refresh on those if you haven't already by the time we get to next video, because we're definitely going to be dealing with our Pythagorean identities and our double angle identities that are going to be very important when simplifying these limit expressions. And I'll also kind of go over a little bit more in depth tomorrow when we're dealing with our limit expressions, like we would have to show on FRQ when it asks calculate, for example, because we're going to have to show every single step and our limit expression with every single step in order for it to count, unless of course we direct substitute, where we can get rid of the limit because we are direct substituting x for a value at that point. But I hope to see you then. We will be continuing with another video tomorrow. And past that, it will be on the weekend, and I will be uploading an SAT video for then. I'll see you guys then. If you haven't already, please subscribe to the YouTube channel. We're going to be continuing going over this review to get you guys 100% prepared when it comes to that AP Calculus BC exam or AP Calculus AB exam in May. I'll see you guys tomorrow. Goodbye.